Alright, so we're going to look at simplifying rational expressions, and we're going to break this up into two videos. This one we're going to talk about multiplying and dividing, and then we'll look at adding and subtracting in the next video. So let's kind of review. Basically, rational expressions are fractions with variables involved. So polynomials or ratio polynomials. So maybe we might need to also look at just fractions, kind of remind ourselves of some details with those. So let's say I wanted to reduce this fraction, and one way I could do that is I could say, well, I know the largest number that goes into 30 and 48 is 6. So I could divide the top and bottom by 6, and that would reduce it down to 5/8. But let's kind of go behind the scenes here and see what's really going on mathematically with this reduction. So what we're going to look at is, for example, the prime factorization of these numbers, 30 and 48. So 30, you think of that as like 6 times 5, and 6 is 2 times 3. So 2 times 3 times 5 makes 30. And then 48, you could think of that as like 6 times 8. So 2 and 3 make 8, or make 6. And then to make 8, you can think of that as like 2 times 2 times 2. So we got 4 2's and a 3 to make 48. And we got a 2, a 3, and a 5. And what we're going to see is any factor that we share on the top and bottom, they're going to cancel each other out. So, one of these 2's is going to cancel out the 2 on the top, and then the 3 on the top is going to cancel out the 3 on the bottom. Now, when I say cancel them out, I don't mean they make 0. What we're really doing is we're basically doing some division. We're saying, what's 2 divided by 2? What's 3 divided by 3? And what we get is 1 in all those cases. And so these, when we're crossing these off, they're basically becoming 1's. And so to figure this out, we're going to say 1 times 5 is going to be what's on top. And then 1 times 2 times 2 times 2 times 1 is what's going to be on bottom. And that's that 5/8. And you can see, when the first problem I did, I divided by 6. Well, that's because 2 and 3 were prime factors that were shared on the top and bottom. That's why that was the greatest common factor. And we see this idea of canceling out these multipliers, these factors, applies to variable expressions as well. So any factor that's shared in the top and bottom, those are going to cancel out, and that's how you're going to reduce a fractional expression. So if I'm looking at this, I can break these down, and you don't necessarily have to go to the prime numbers, or you don't have to list out x times x for x squared. But what we're looking for is matching things on the top and bottom. So I'm going to break these down. I'm going to say, oh, well, 10, 2 times 5, 25, 5 times 5. That way I got some 5's I can cross off. And I can say, well, okay, I got an x squared on top. Let's break down x to the fourth as an x squared so I can match. And then, an x squared for the leftover parts. I have a y to the third on the bottom. So let's break up y to the fifth as a y to the third. And then, however many y's are left, so y squared. I can just start crossing things off here that match. So a 5 on top will match a 5 on the bottom. X squared on top will match an x squared on the bottom. A y to the third on top will match a y to the third on bottom. And I can say, okay, what is left after I've done that? And I have a 2 times y squared and a 5 times squared. So after I make all of these 1, I get 2y squared over 5x squared. And again, you don't necessarily have to write all that work out. You could, just cross off your y cubed and then cross off your y to the fifth and rewrite it as y squared. But I'm trying to show what we're doing is we're canceling out multipliers, canceling out factors. So that's going to be the big deal, is we're going to do a lot of factoring in this, in these sections covering multiplying and dividing, adding, subtracting. All right, so let's say I wanted to reduce this expression. Now, I'm going to do something here, and I hope you feel like what I'm doing is kind of silly, because it is. It is silly, but I want to do it just to prove how silly it actually is. So let's say I was looking at this, and for some reason I thought, hey, there's a 4 on top and an 8 on the bottom. Can't those cancel each other out? Can't 4 go into 4 once and 4 go into 8 twice? Couldn't I do that before I added the 4 and the 3? Well, what would happen if I did that? So I now have a 1 there, so 1 plus 3 is 4, and then a 2 on the bottom. So 4 divided by 2 is 2. And then, okay, well, is that okay? Well, no, it's not okay. Because if I had 4 plus 3 over 8, 4 plus 3 is 7 over 8, which is a lot, which is less than 1. How is that ever going to be 2? It doesn't make any kind of sense. Now, the reason why I'm talking about that is because we're going to have expressions like this to simplify. X squared minus 7x minus 18 over x squared plus 2x. And sometimes people are tempted to say, well, can't I start crossing things off yet? And the thing is, those terms are not factors. No more than the 4 and the 8 in the example I just did were factors. I couldn't just start crossing things off there. Now, the difference is obviously if all you're dealing with is digits, you can just add 4 and 3 and get 7, and here I can't because I don't have like terms. But remember, variables represent numbers. That's what they fundamentally, they're just numbers. I don't know what the actual value is at the moment, but they're numbers. So anything you can't do with numbers, you still can't do with variables. So I can't just start crossing off, hey, I'll cross off x squared and x squared. It doesn't work. You have to cancel factors. And what that requires me to do then is to factor these expressions. And so we're going to factor the top and factor the bottom. The top is going to factor, again, I'm going to go through my list. Greatest common factor, grouping, specials, and then product of binomials, and this is a product of binomials. So what are the factors of 18 that are different by 7? 9 and 2, they're different signs. The bigger one is whatever is in the middle, so the bigger one in this case is negative. So negative 9, positive 2. On the bottom, again, I'm going to start at my list. GCF, I have an x in common. I can factor that x out. So you should always be going through that list when you're factoring. And now I'm going to look to see what matches. Now what matches here is an x plus 2 on the top. Notice those are factors that are in common. That's why I can cross them off. And what's left over are the factors x minus 9 and x. And sometimes people drop the parentheses off in this case because the top isn't actually multiplying anything at this point. But I would recommend you leave it there just to remind yourself, that's not x minus 9, it's x minus 9. It's a quantity, it's a factor. And so that factor is totally different than x on the bottom. So you cannot simplify this expression any further. All right, let's look at this problem. So this problem has a few issues with it. The first issue is you notice the top is in the wrong order. So maybe I might want to rearrange that order or put the negative x squared first and the 10 last. But again, I still have an issue here where I have a negative x squared, and I would rather that be a positive x squared. So I'm going to factor out a negative, basically a negative 1 on the top. You get x squared plus 3x minus 10 in there. So that changes all those signs. And now I'm going to factor this. So again, top, I'll go through my list. GCF, well, you can think I took the negative out. That's a GCF. Grouping, no, I only have 3 terms. Special ones, no, it's none of the special ones. So product of binomials, what are the factors of 10? Different by 3, 5 and 2. And they're different signs, bigger ones, whatever the middle sign is. So positive 5, negative 2. On the bottom, you have x squared minus 25. That's the difference of squares. So x plus 5, x minus 5. And now I can look, and don't forget that negative that I factored out. That's still part of the expression. And so now I can cancel out those x plus 5s that match factors. Remember, I'm canceling factors. And I get what's left over. So I have a negative and then a fractional expression, x minus 2 over x minus 5. And again, you could drop the parentheses, but I would leave them. Another reason, especially in this, is if you were to draw all that negative side so it looked like it was with the top, and you didn't have the parentheses, then you'd look like you were saying negative x minus 2, which is not the same as negative quantity x minus 2. So keeping those parentheses can help you protect yourself from making sign errors when you've done all the rest of this work correctly. All right, so simplifying expressions, we have to cancel factors. All right, so let's look at some actual operations of these expressions. So let's say I want to multiply these two fractions. So one way I could do it is I'd say top times top, bottom times bottom, 20 times 49, 14 times 25, and then try to break it down. But usually what's easier is to look for things that you could cancel before you multiply. So that might be two things in the same fraction. So for example, maybe I could cancel, reduce down 20 and 14, say, well, they're both even, 2 goes into both of them. So 2 goes into 20 10 times, 2 goes into 14 7 times. So that's one thing you can do. You can do canceling within the same fraction on the top and bottom. Another thing you could do is you could cancel, because of the way you multiply fractions, top times top, bottom times bottom, ultimately it doesn't matter if a value is in the top of the first fraction or top of the second fraction. All that matters is if it's in the top. Same thing with things in the bottom. It doesn't really matter if it's in the bottom of the first fraction or bottom of the second fraction. All that matters is it's on the bottom. So I can, for example, look at and say, hey, 10 has a factor that's in common with 25, 5. So 5 goes into 10 twice, and 5 goes into 5 times. And the same thing with 7 and 49. 7 goes into 49 7 times, and 7 goes into 7 one time. And this is getting a little clustered, and which is why one of the reasons why it's nice to write out the factors before you start crossing everything off. But you can see I'm canceling things either on the top and bottom of the same fraction or the top and bottom of different fractions. And those are both ways of canceling. And then once I've canceled out everything that was on the same from the top and bottom, then I'm just going to multiply across. So 2 times 7 is 14, 1 times 5 is 5, 14 over 5. So that's going to be the kind of the thought process when we start working with variable expressions. So let's say I'm looking at these. And what I first want to do is figure out what are all the factors. Now, if you look at 4x squared y, those are already multiplying. So those are already factors. Same thing with 5x y squared. Those are already multiplying. Those are already factors. The problem is with the 2x squared minus 18 and the x squared plus 4x plus 3. Those are adding and subtracting. Those are not factors. I have to get it into a multiplication. So I need to do some factoring. So let's start with the 2x squared minus 18. GCF. Hey, they're both even. Must be a 2 in common. So I factor that out. 2 times x squared minus 9. X squared minus 9. No GCF, no grouping. But it is a special one. This is the difference of squares. X squared minus 9 is x plus 3, x minus 3. So that's factored down as far as I can. So now I'm going to jump up to the numerator of the second fraction, x squared plus 4x plus 3. And again, I go through GCF, no, grouping, no, special, no. So product of binomials, I'm looking at what are the factors of 3 that add and give you 4. Well, 1 and 3. So x plus 3 and x plus 1 are my factors. And now I can start crossing some things off. So, and again, they could be within the same fraction or they could be in different fractions. So I could cross off an x plus 3 on the top of the second fraction as long as I cross off an x plus 3 on the bottom somewhere. And I see I have one of those in the bottom of the first fraction. Another thing I can cross off is I can cross off my 2 on the bottom of the first fraction, that GCF, and my 4 on the top of the same fraction. See, I don't have to go to a different fraction. I can stay within the same fraction. As long as, again, one's on top, one's on bottom. So 2 goes into 2 once, 2 goes into 4 twice. And then I can cross off maybe some variables here that are multiplying. So I got x squared, that'll cancel out an x, and that'll leave me 1x on top of the first fraction. And I got a y and a y squared, I can cross those off, and that'll leave me with a y on the bottom of the second fraction. And now, it doesn't look like we have anything else that matches on the tops and bottoms that are factors, and so I can put this together. 2x times x plus 1 on top, and it looks like we got a 5y times an x minus 3 on the bottom, and there we go. There's our factors. And it's reduced down to lowest terms. Alright, so let's look at this problem. This is probably a little bit more typical of the type of problem you would see, where you have 4 polynomials you have to factor, and they're all going to be the product of binomials. So factors of 8 that give you 6, 4 and 2, and they're both negative in this case. And I usually go top of the first, bottom of the first, top of the second, bottom of the second. That's the order I'm going to work these in. So x squared plus 5x plus 4, again, factors of 4 that add and give you 5. In this case, they're both positive, 1 and 4. And then moving on to the top of the second fraction, factors of 2 that add and give you 3. Well, 2 and 1 are the only factors of 2. And then this last one, factors of 8 that are different by 2, well, that would be 4 and 2. Again, they're different, so the bigger one is negative. So negative 4, positive 2. And now kind of the fun part, it's, seeing what matches and crossing it off. So anywhere on top with anywhere on the bottom. So we have an x minus 4 on top and an x minus 4 on the bottom. Those cancel out. Looks like we have an x plus 2 on top with an x plus 2 on the bottom. Those will cancel out. And x plus 1 and x plus 1. And that's it. That's all we have that cancels out. So what we have left on top is an x minus 2 and an x plus 4 on the bottom. And there's our answer. So that's the typical type of problem you're going to run into in a multiplication. It's factor, 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 and then just start crossing things off. And remember, when we cross these off, they become ones. I'm not going to usually write a 1, just, as a reminder, 1 times anything is that number. So, these all become ones when we cross them off. They don't go to 0. It's a big deal. All right, let's look at dividing. So that's how you multiply. How do you divide? Well, the way you divide is actually you just multiply, but you multiply by the reciprocal of the second expression. So if I had this problem, x squared minus 9 over 2x squared minus 15x plus 18 divided by 6x squared plus 11x plus 3 over 3x squared minus 17x minus 6, the first thing I'm going to do is I'm going to change this to a multiplication, and I'm going to flip that second fractional expression over. I'm going to take its reciprocal, and that's what I'm going to factor. Now, these are all basically, the hardest type of factoring here, except for the first one. That's just the difference of squares, 4x squared minus 9, so 2x minus 3, 2x plus 3. So you might need to do some scratch work on the side if you want, or you do a bunch of work and then rewrite all these together. I'm going to do a little bit more intuitive method of factoring here, so you might want to do it yourself and then see that you get the same factoring form as I am doing, or you can try to follow along and see if you understand how I'm doing it and do it that way. So what I'm going to do on this bottom of the second one, and again, you should be checking for GCFs and groupings and special ones. None of those have these here, but you should check, in case you're unsure. So what I'm going to do is I'm going to take 2 times 18 and get 36, and I'm going to ask myself, what are the factors of 36 that add and give you 15? And if I go through the list, 1 and 36, 2 and 18, 3 and 12, there we go. And I want them both to be negative. They're both the same, that's why I'm going to add them, and they're looking at the middle sign, they both have to be negative. So what I'm going to do is I'm going to start off by trying to make negative 12. And I'm going to use part of 2x and part of 18 to make that. So I think, 2 can go into 12 6 times, and I know 6 goes into 18. So I'm going to put a 2x at the beginning of my problem and a negative 6 at the end, so that when I do my FOIL, my outside pair will make that negative 12x term. And then I'm just going to use the fact that first times first makes first, so 2x times the beginning of that second one has to be an x. And last times last makes last. Negative 6 times that end of the first one must be a negative 3 to make it positive 18. So that has to be a negative 3, that has to be an x. There it is factored. So that's kind of the more intuitive way if you want to try to do it. And I'm going to do that for each of these. So 3 times 6, 18. What are the factors of 18 that are different by 17? Well, 18 and 1. The bigger one has to be the negative one, since that's a negative 17. And so I'm going to form negative 18 by using part of 3 and part of 6 as my outside pair. So I'm going to begin with my first parenthesis with 3x, and then I'm going to end my second parenthesis with negative 6, and if I multiply that outside pair, that would give me my negative 18x. And again, first times first is first, so 3x times x, and last times last is last, so negative 6 times positive 1 is negative 6, so that will give me the complete factoring there. And then 6 times 3, 18. What are the factors of 18 that add and give 11? And the answer is, 9 and 2. So to make a 9, I'm going to use a 3 out of 6, and then that 3 at the end. So I'm going to start the first parenthesis with a 3x, times 3 at the very end. That'll make my positive 9. And again, first times first is first, so 3x times 2x. Last times last is last, so 3 times positive 1. And there that is factor. So there it is factor. Like I said, if you're not quite sure how am I getting all this to work out, but you know how to do it the longer grouping method, you might need to do that for all 3 of those off to the side somewhere, then bring that information and put it in the right spots. And now we're ready to start doing some crossing off. So look to see what matches. We got 2x minus 3 on top, 2x minus 3 on the bottom. Those cancel each other out. We got a 2x plus 3 on top and a 2x plus 3 on the bottom. We got a x minus 6 on the bottom and an x minus 6 on top. And we got a 3x plus 1 and 3x. Well, okay, that's interesting. Everybody crossed off. So what does that mean? My answer must be 1, right? Because if you're multiplying and dividing and you get everything to cancel out, that must mean you've gotten 1. You don't get 0 unless you started with 0. That's the zero product principle. But if everybody cancels out here, this must have been 1. So that is how you do that problem. So a lot of factoring. Just remember when you're dividing, you're going to multiply by the reciprocal. And I will tell you, if an instructor was kind of required to only be able to ask you one question, whether it was a multiplying or dividing, I would guess the instructor would ask you the dividing question, because with a dividing question, the very first thing you're going to do is flip that second one over and turn it into a multiplying. So by asking a dividing question here, they're actually asking a multiplying question with extra step at the beginning. So keep that in mind, that multiplying, just start factoring, crossing things off. With dividing, you have that one little extra step at the beginning where you have to flip over the second fraction and then factor and start crossing things off. All right, so that's our first discussion about rational expressions.